Assalamu alaikum. So my name is Nauman Arif and my topic for the compiler is removing left recursion from the grammar. So to start with my topic, firstly we need to understand what is left recursion. So left recursion is nothing more than a function calling itself again and again before doing any other task. For instance, in the given example, the leftmost element E, which is also on the left hand side, firstly calls its own self as E is calling E and then performing other tasks, which is plus num or num. So in the second example, similarly, firstly the S is the leftmost element which occurs, so it has to uh, S calls itself firstly and then it perform other tasks. Now the question rises that what is the difference between left recursion and right recursion? So to compare both of them, we have to look into the example of both. Firstly, as we discussed above, that the left recursion is a function calling itself before doing any useful task. It's the function which is at the most left side of the expression or the grammar. So it calls itself firstly and then do any other task. Whereas in the right recursion, as we can see that the E is on the rightmost side of the expression plus num and then it's E. So it's when we consider it in a code, so the E will calling itself after performing some sort of a task. For instance, here the E will firstly perform plus num task and then it will be calling the E function itself again. So it will not be a problem for us to deal with the right recursion. So we have to tackle the left recursion only. Now to start with our main topic, that is removing the left recursion from a grammar. To understand this concept, we have to look into a formula first and then we will go into the example part. So the formula says that A goes to beta A prime and then A prime goes to either null or epsilon and then alpha A prime. So basically we have to map whatever the grammar is given, we have to find out what is alpha and beta in that specific grammar and have to map that grammar according to this formula so that we can remove the left recursion easily. So to start with our example number one, that we have to remove the left recursion from E goes to E plus num or num simply. So the solution, as we have mentioned the formula in the previous slide, we have to map, we firstly have to locate what is alpha and beta in the given equation, in the given expression. So here the number which is the rightmost side of the equation is beta, and except the part the left which is causing the left recursion, which is E itself, the other part of the statement is going to be alpha. So here I have highlighted in the red portion that num is the beta, which is the other half of the equation, and the alpha part is only the plus and num, whereas we are skipping the E, which is the left recursion part. Therefore, then according to the given formula, we have to map it accordingly. So after looking into the formula that A goes to be alpha, we have we have located that alpha is going to be the plus num and beta is going to be num. Therefore, putting the values in the equation, so E goes to num and E dash then goes to either epsilon or the alpha part, which is plus num, and again it is calling itself E prime. So here we have easily removed the left recursion, as we can see that E is not directly calling its own self. Firstly it performs num and then it calls E prime, and similarly E prime again does not call itself, but it firstly performs plus num operation and that it is calling itself. So therefore we have removed the left recursion from this grammar. So let us take another example which is a bit more complex than the previous one. Here E goes to E plus T and E minus T or simply T. Similarly, T goes to T multiply F or T divided by F or simply F. And lastly, F goes to ID num or expression, which is E. So to start with, here we firstly need to understand that here E is also causing the left recursion as well as T. As we can see that both E is the most leftmost element as well of the grammar, and T is the most leftmost element too. So we have to firstly identify alpha and beta in both E and T so that we can further perform the mapping in the formula. To start with, we firstly need to identify alpha and beta here. So as we know that the most rightmost element is going to be beta. So here the t in the first expression of e is going to be beta, and here we are going to have multiple alphas because e plus t and e minus t, both of them are causing the leftmost recursion here. So excluding the part of E, plus T and minus T both are going to be alpha. So we named it plus T named as alpha 1 and minus T is named as alpha 2 and T is going to be beta. Similarly in the T, the multiply T and the asterisk T or asterisk F or the slash F are the alphas here in the T equation, and simply the last one F is going to be beta. So we have identified alpha and betas in both of the equations. So we simply have to put and map them in the equation and the formula which has been discussed above as well. So as we have already known the alpha and beta values of both E and T, so we can easily put them in the formula which have been discussed above. Therefore, E goes to T and E prime. Here T is the beta value and E prime is definitely the element which is helping us to remove left recursion. So E prime goes to epsilon, or E prime also goes to plus T and E prime or minus T E prime. Therefore, removing the left recursion from the E part. Similarly, for the T, we know the alpha and beta in the above slide. Therefore, T goes to Ft, where F is the alpha, is the beta value, and T is going to be the T prime is going to be the element which is removing left recursion. T prime it goes to epsilon or asterisk F or T prime or slash F T prime. Here we have also removed the left recursion from the grammar, but from T, and also we have removed from E. So finally, as we know that there is no left recursion in F, so we can put it as it is. F goes to ID, num, or expression. So that's all from my side. Thank you very much.